Hello viewers, today I'm discussing about circle diagram. So in the previous session we discussed about circle diagram of induction motor. Today I'm discussing the complete circle diagram and extension of extension of part 1 video. So today I'm discussing about complete circle diagram. So nothing but complete circle diagram means slip and slip and resistance changes from minus infinity to plus infinity. But in the previous case we discussed about the slip is from, look at this one, plus infinity. This is nothing but r is in plus infinity to nothing but somewhere else, r is somewhere else, but we need to discuss now plus infinity to minus infinity. Look at this one, plus infinity to minus infinity. How that will takes place, I'm going to explain now. So yesterday in the last class I discussed about this is nothing but I naught from the no load test, and this is nothing but IBR block rotor test, and this is nothing but no load and block rotor test, and under load condition these are the different values I2 dash, I2 double dash. These are the different loads of full load, these are the currents at different loads of full load and 1 by 2 full load, 1 by third full load, and 3 by fourth full load, and at a different loads current will be like that. And now, so in the part 1 video I covered only this portion of the circle, only this portion of the circle, and remaining portion is there, this one remaining portion, and also remaining semicircle portion also is there. Today I am discussing remaining total. So so how the remaining portion will be, so let us discuss by using the these conditions. So this is the rotor equivalent values refers to primary, rotor equivalent values primary to refer it primary. This is nothing but r2 dash and x2 dash, and this is nothing but mechanical equivalent of a rotor resistance. And I shifted all the values in the towards the stator, and the total equivalent resistance is nothing but r01 is equal to r1 plus r2 dash, and also include r2 dash into 1 by s minus 1. So this is the total resistance of induction motor refers to primary. Thus this is primary. So by changing the slip, look at this one, by changing the slip, how the mechanical equivalent of rotor resistance changes, and how it will be, and I will discuss now. So first of all, yesterday I discussed about under no load condition. Under no load condition, how the net resistance is nothing but total value of the resistor. Under no load condition how it will be, under load condition how it will be, and under short circuit condition or block rotor test how it will be. So r01 is nothing but r1 plus r2 dash plus r2 dash into 1 by s minus 1. But r1 nothing but stator resistance is very less, so that I'm neglected, so that I took net resistance as r2 dash plus r2 dash into 1 by s minus 1. Viewers, I'm neglecting r1, remember this one, I'm neglecting stator resistance because the stator winding having highly reactive, so that I'm neglecting resistance of that winding, so that I'm taking net resistance. If I include, this becomes grass resistance. If I remove this one, this becomes net resistance. So look at this one, under no load condition, rotor speed approximately equal to stator speed, so that slip is 0. If slip is 0, look at this one here, if slip is 0, 1 by 0 is nothing but infinity. Infinity minus 1 nothing but total infinity. So under no load condition, infinity. Look at this one, r is infinity. R is infinity. So so net resistance is also infinity. Look at this one. If this is infinity, net resistance also infinity. Next, I2R dash. I2R dash nothing but rotor current, refers to stator. So V by R2 R01 or R net resistance plus X01 whole square. Net resistance is infinity, so but something by infinity is 0. Rotor current is 0. Under no load condition, rotor current is 0. So under load condition, as load increases on the induction motor, how it will be? So as load increases, rotor speed nr decreases, so that slip also increases. If slip increases, that the previous case, if slip is 0, resistance is infinity. If slip increases, the resistance value decreases from infinity. Now if it is decreasing, rotor current increasing. So look at this one, only everything is here only of induction motor working under these conditions. So as mechanical equivalent resistance decreases, rotor current increases. So this is next, under short circuit condition or block rotor condition. How it will be under block rotor condition? A rotor speed is 0 because we are blocking the rotor. So that nr rotor resistance is, the rotor speed is 0. That's why slip is 1. Look at this one, R2 dash mechanical equivalent value of the resistor is 1 by 1, nothing but 1, 1 minus 1 0, nothing but rotor resistance equivalent to mechanical value is 0. That's why net mechanical resistance is nothing but R01, which is equal to R2 dash, which is equal to R2 dash. So which is equal to R2 dash. Some resistance is there, so that at this condition the rotor draws maximum current. Under block rotor condition, the rotor draws maximum current and maximum copper losses takes place. So look at this one. This is nothing but IBR, block rotor current, and R net resistance is equal to R2 dash. R2 dash means resistance changes from infinity to R2 dash, R2 dash, and this is the induction motor under no load and load and short circuit conditions. This gives us block diagram. This gives us this area of circle diagram, only this area of circle diagram. So remaining portion will be as shown in below. Look at this one. So let us discuss braking mode. So let us discuss the braking mode. So generally, uh, induction motor operates in three modes. First one is motoring mode. Second one is braking mode, and the third one is generating mode. So motoring mode is completed. Now is generating mode, sorry, braking mode. So under braking mode, the rotor, so parameter variation will be like this. So under braking mode means how we should apply the brakings to the motor. So because if the, for example, the applications of induction motors are traction. In traction applications, generally the rotor continuously rotate for a long time, and if a station comes, we should apply brakings and we should stop the motor. So we should apply the electrical braking nothing but generally by changing the RYB. Okay, three phases are there na? By changing the RYB phases, nothing but phase sequence can be changed by changing any two terminals, RBY. This is nothing but if you change the phase sequence, the synchronous field will be reverses, so that synchronous field and rotor speed will be opposite. That's why the rotor becomes slow down fastly. The That's why we should apply the braking to stop the trains and heavy vehicles. We should apply the brakings. That is nothing but electrical braking. Under braking conditions, under braking condition, by changing the RYB phase sequence, RYB to RBY, though, so that the synchronous field will be reverses. Synchronous field will be reverses in the previous direction, so that I'm slip is nothing but minus ns, because the speed is reversed. Synchronous speed is reversed by changing this one. So ns plus nr by ns, this value is always greater than 1. Nothing but slip is greater than 1. Under block rotor condition, slip is greater than 1. Next, net resistance is R01 is equal to R1 plus R2 dash, and I already discussed R01 approximately equal to R2 dash, and now net resistance is R2 dash plus this one, because I neglected R1 R0 R1, because road stator resistance is very less, so that I am neglected this one. So the net resistance will be R2 dash plus R2 dash into 1 by S minus 1. So look at this one. Under braking mode condition, slip is greater than 1. Slip is greater than 1. If slip is greater than 1, look at this one. If is greater than 1, nothing but let us take 2. 1 by 2 is nothing but 0 0.5. So 1 by 2 is nothing but 0 0.5. 0 0.5. 0 0.5 minus 1, nothing but RG net resistance is negative. Net resistance value is negative. Under braking mode condition, slip is greater than 1, so that this value is negative. This value is negative. So in the network theory, we know very well about the network theory, that if a resistor absorbing energy, so current entering in this direction, the terminal will be positive and negative. So if anything that releases the energy, anything that delivers energy, for example this one battery, this is positive and negative. It is delivers the energy to the resistor. So always current direction is negative, nothing but negative to positive. Here the resistance, mechanical equivalent resistance is negative, nothing but, look at this one, current direction is opposite to the previous one. Nothing but under braking mode operation, the rotor behaves as generator, nothing but it generate, it give the back, it give the supply to the back. That's why under black load condition, the mechanical equivalent value is negative. Negative as goes on increases. So as under immediate after applying the braking, after applying the braking to the induction motor, this negative value will be maximum, and it will reaches, and by increasing the braking, the total value, negative value decreases, and only R2 dash exists. Nothing but after applying the braking, motor get rest position. Motor get rest position. Rest position nothing but 1 by S is 1, nothing but under block rotor conditions. Motor getting rest position is nothing but block or rotor test. So this value will be 0, only this one exists. So look at this one. So immediate after applying the brakes, R2 dash approximately equal to R2 dash into 1 by S minus 1, because under immediate after applying the brakes, the maximum generation, so that this value will be maximum, which is maybe equal to R2 dash. So as braking applies to the rotor, and this value will be reduces, and this will goes equal to the block rotor condition. Under block rotor condition, only net resistance exists, nothing but R2 dash only exist. R2 dash only exist. So we should apply the brakings. So suppose let us take here the speed of NR is rotor speed is 1400 rpm, 1400 rpm. At this condition maximum generation takes place, so that equivalent resistance of mechanical value will be equal to the R2 dash. This is R2 dash, so that net resistance is 0, net resistance is 0 under braking mode. And as long as braking will be continued, the rotor speed reduces and mechanical equivalent value reduces, because slip also changes. Slip is decreases, so that the rotor becomes rest position under block rotor condition. That's why under block rotor conditions we discussed earlier that net resistance is equal to R01. So this is the behavior of the induction motor under braking mode condition. Next, let us discuss the generating mode of induction motor, induction machine, induction machine. So look at this one. So net resistance is R2 dash into R2 dash plus R2 dash into 1 by S minus 1. Generating mode nothing but when the induction machine act as a generator, rotor speed is greater than synchronous speed. Rotor speed is greater than the synchronous speed. Then at this condition, the induction machine operate as a generator. So if it is greater, so negative, nothing but NR is greater, the slip will be negative, the slip will be negative. These are the basics. As long as if you increase the rotor speed, as long as you increase the rotor speed, the slip is becomes more negative, slip is more negative, and net resistance becomes more negative, net resistance also increases from negative value. So look at this one. I already discussed it in the uh, mo- in the previous motoring mode and braking mode, how the net resistance changes under generating mode. This value becomes more negative, nothing but under generating mode it generates something, it generates current, so that this becomes more negative, nothing but more current will generate. So as long as increases the speed, the look at this one, no? NR increases, slip becomes increases, and it reaches to the infinity, because it is negative, so that minus infinity, like this is the variations, like this. As long as increases the rotor speed, it will reaches to the minus infinity, or net is equal to minus infinity. This is the point where we took or net is equal to plus infinity in motoring mode, and in generating mode this is minus infinity. So that's why the net resistance changes from minus infinity to plus infinity. This is the complete circle diagram. So the complete circle diagram is minus infinity to plus infinity. So the here under motoring mode condition, under no load, this is plus infinity. Under generating mode, this changes, r is equal to 0 changes and increases in this direction, in this direction resistance decreases, reaches to 0, minus infinity to 0, and 0 to minus infinity. This is nothing but motoring mode. Up to here this is nothing but braking mode, and here onwards generating mode of induction machine. So let us compare all these three cases: motoring mode, and braking mode, and generating mode. So in under motoring mode, the slip changes from s is equal to 0 to 1. So under this condition, net resistance is minus infinity to r01. So let us clear this one. Under motoring mode operation, slip changes from 0 to 1. Slip changes from 0 to 1 means resistance changes from plus infinity to r01. So look at this one. This is nothing but r is equal to plus infinity. So this is nothing but IBR. IBR nothing but under block rotor condition. So the resistance, R net resistance is R01. R01 because under block rotor condition slip is equal to 1. 1 by 1 nothing but 0. This value is 0 nothing but net resistance is R2 dash nothing but R01. So net resistance is positive. Net resistance positive means the motor absorb the power. Motor absorb the power. That's why this is called motoring mode. Motor always absorb the power. So that net resistance is positive. And under braking mode, slip is greater than 1. So I already discussed it earlier. Slip is greater than 1 and 1 to infinity. Nothing but this portion. This portion. Slip is from 1 to infinity. So net resistance changes from R01 to 0. So how did this takes place? In braking mode operation, this is R01. This is always positive. Always positive, nothing but it sinks and it absorbs the power. And this is nothing but mechanical equivalent value of the rotor, mechanical equivalent resistance of the rotor. So which is negative? Why which is negative? Because slip is negative. Slip is negative nothing but which generates the, which is a source of active power. It is the source of active power. So source of active power is maximum at applying the brakes, and it reaches to the, and the both value will be equal, so that resistance value is 0 under applying brakings to the motor. So that's why the variations will be under braking mode. The R01 is sink nothing but it is a, it absorbs always power. R2 dash into 1 by s minus 1 nothing but generation. So it generates source of active power under braking mode operation. Next, let us discuss the generating mode. Generating mode operation, the slip is changes from minus infinity nothing but 0 to minus infinity. So resistance, net resistance also changes from 0 to minus infinity nothing but in this portion here R net is equal to 0, and here R net is equal to minus infinity. So it changes from 0 to minus infinity. So it means this is sink of active power. This is nothing but source of active power. So it is always source of active power nothing but generation is greater than the sink, so that this is always negative. So that's always negative nothing but source nothing but generator. So always is generates power, active power. That's why this is nothing but generating mode. This is a complete circle diagram of a induction machine. So this is all about the induction motor. And after watching the part 1 video, we can understand part 2 video. It is very difficult to understand part 2 video without part 1.